The White House pulls Jared Isaacman's nomination. The 2026 NASA budget is released. The Hubble tension might not be a problem after all. The Milky Way and Andromeda might not merge after all. And on SpaceBites Plus, why ozone isn't a good biosignature. All this and more in this week's SpaceBites. So we've learned that the White House has decided to pull Jared Isaacman's nomination as the NASA administrator. And if you haven't been sort of keeping up to this story, several months back, we learned that the White House was suggesting that Jared Isaacman would be their proposed NASA administrator. And this was a recommendation that came from Musk. Jared Isaacman is the money and the sort of driving force behind Polaris. And they have done a couple of private space flights, including a spacewalk that Jared Isaacman did. And he was a controversial pick as a NASA administrator. Like, on the one hand, he had no experience in the bureaucracy of the federal government, in NASA. But on the other hand, he is a successful entrepreneur and clearly loves spaceflight. He's sort of dedicated his life to this. He's a pilot and has actually flown to space twice. So, that's pedigree. And so his name was put forward and it was confirmed by the Senate. And so we were all expecting this was a fait accompli. It'd just be a matter of time before Jared Isaacman took over the reins at NASA. But this week we've learned that the White House has decided that they're going to remove his nomination. And so he will no longer be their pick for the NASA administrator. Now, why this happened behind the scenes? I mean, there is some infighting that's going on right now between Elon Musk and Donald Trump. And the general impression is that Isaacman wasn't getting in line with the priorities of the White House. And so they've decided to go with somebody new. But we don't know who their new administrator choice is going to be. They're going to announce that shortly. And this leads us into the NASA 2026 budget. We saw the skinny budget several weeks ago, and now we finally seen the full budget, the comprehensive version of what the White House administration is asking for. Now, this cuts the NASA budget from about 25 billion down to about 18 billion. And it cuts a bunch of programs. So right on the chopping block is the Lunar Gateway, which was going to be this halfway point between the Earth and the Moon, the station where astronauts could go and stay before they go down to the surface of the Moon. So that's cut, even though a lot of the modules have already been completed. Then we would see the cut of the Space Launch System and the Orion capsule after Artemis 3 completes. And so we've got Artemis 2, which is going to launch to the moon, and then Artemis 3, and then that would be it for that platform. There's a lot of other cuts to environmental science, education, outreach, advanced research, and other what they call low priority areas. Cuts to the workforce, IT facilities, and construction and environmental compliance. STEM outreach gets an outright cancellation, 100% cut. And I rely a lot on NASA's STEM outreach, which, is fine. I'm a journalist. I can dig. Our team can dig, but still, the STEM outreach work that NASA does has been great, and I think has been really influential to a lot of people out there. We do see a boost in funding to commercial space operations, and there's like a bigger emphasis on sending people to Mars. You've got some funding for spacesuits that could work on Mars. And I know a lot of you were quite worried about various science missions. So the Mars sample return mission is definitely canceled, while Dragonfly and Nancy Grace Roman are still going to be moving forward. So that's where we stand right now today. Now, if you're worried about the NASA budget, this isn't the end yet. Now that you've gotten the first proposal that's come from the White House, it then has to go through Congress and it has to get Senate approval. And there's a lot of people on both sides of the aisle that are quite excited about space exploration, as well as a lot of the missions and construction. And a lot of the employees and the workers are in their districts. And so it could very well be that people are going to stand up and they're going to try to come up with a different budget for NASA. And we've seen this happen in the past. So right now, this is the proposed White House administration budget, but it is not the official budget yet. We'll have to wait until all of those votes have happened before we can finally see what the results of this are going to be. And we've got a great story about the budget from Matt Williams on Universe Today. At the time that I'm recording this, it's about 2 hours after the ispace Hakuto R Mission 2 Resilience lander attempted its landing on the moon. And this was important because the first attempted landing failed. And so this was the chance to demonstrate that they worked out all the bugs, solved the problems, and they were going to land. And Resilience was supposed to touch down on the surface of the moon at the same place that the original lander was supposed to touch down. iSpace did a live stream of their landing attempt, and everything seemed to be going great. And then the transmission cut at about 90 seconds before it was supposed to have landed. And in the final moments, it was still descending at thousands of meters per minute, which is way too fast to be able to do a safe landing. And then iSpace put a message on Twitter where they said that they haven't been able to establish communication, and so that doesn't sound good. The great galactic ghoul has eaten another lander. We've talked a lot about the Hubble tension here on the channel. This is this mismatch between the measurements of the expansion rate of the universe. When you measure it locally, you get one number, and when you measure it in the cosmic microwave background radiation, you get a different number. And for the longest time, these two numbers were close enough and their error bars were large enough that they overlapped. And so you assumed that it was going to be some number in between those two measurements. But recently, the measurements of the closer part of the universe has gotten a lot better. And in fact, the error bars have narrowed to the point that they no longer overlap, that the expansion rate of the universe as we measure it nearby is different from the expansion rate of what it should be in the cosmic microwave background radiation. And this has led to what astronomers call the Hubble tension, where there's something else going on. Maybe that we just don't understand how the expansion of the universe works. Maybe there's additional physics. This was really exciting. This was a chance for new ideas to be able to be tested and to maybe overthrow the standard theory of cosmology. And like having new mysteries is always great. But now a new study has gone and evaluated the distances to the nearby universe, looking at the Cepheid variables, looking at Type 1a supernova, and they've used data from both James Webb and the Hubble Space Telescope, and what they found is that the error bars do overlap again. So they found that the expansion of the universe is 70.4 kilometers per second per megaparsec with a 3% margin of error. And when you go back to the cosmic microwave background radiation measurements, which were done with the Planck satellite, you get 67.4 plus or minus 0.7%. And so when you do the math, those numbers do overlap. And so one possibility is that in fact, there is no tension, that the better measurements are actually bringing those numbers back in line and that the standard model of cosmology holds up. And that's not surprising. I mean, the standard model of cosmology is really good and has held up to all kinds of assaults from many different directions, but it does make me a little sad because it's quite exciting to see possible new avenues. And I think a lot of astronomers had been hoping that there was a place where they could start to chip away at, some of our understandings about how the universe works. And maybe this would give us glimpses into what is the nature of dark matter and dark energy. But it feels very familiar to what happened with particle physics, that they discovered the Higgs boson and the standard model of particle physics is kind of held together quite nicely. And so it's hard to make new progress. Now, we've got a great story about this from Mark Thompson on Universe Today. Another story that we talk a lot about is the fact that the Milky Way and Andromeda are doomed to merge in the far, far future. When you look out into the universe, galaxies are moving away from us. The farther they are away, the faster they're moving away from us. But there's a few exceptions, some dwarf galaxies and a few galaxies in our local group. The largest of this is M31 Andromeda, and this galaxy appears to be barreling straight towards us. And it was assumed that we were going to merge with Andromeda at some point in the next few billion years. They would start with swiping at each other, and then they would fall into various star streams and tails, and then eventually would all come together and form a giant elliptical galaxy like M87. But now there's a new paper that says maybe not so fast. So what the astronomers did was they considered all of the parties of this upcoming collision, not just the Milky Way and Andromeda, but they looked at the gravity effects of the other large galaxy in our area, and that is M33, which is a galaxy in Triangulum. They also looked at the Large Magellanic Cloud, and then considered the gravitational interactions of these four galaxies. And what they found was that in about 50% of the simulations that they ran, the Milky Way and Andromeda don't merge. They interact with each other gravitationally, but then they fly away from each other and don't form this giant elliptical galaxy. And that's because of the gravitational interactions between all 4 of these galaxies. So I guess stay tuned for 10 billion years to find out whether or not it's actually true. And we've got a story about this by Evan Goff. When NASA's New Horizons flew past Pluto in 2015, 10 years ago, wow, it gave us the first pictures of the surface of Pluto and its giant moon Charon. And we learned so much. I mean, we thought that it was going to be this just frozen, icy world, but the images show that it actually has this active resurfacing. It has glaciers of stuff that would be gases in our atmosphere here on Earth. But it has its own atmosphere. It has this very hazy atmosphere of nitrogen, methane, and carbon monoxide. And when New Horizons completed its flyby, it looked back and peered through the atmosphere of Pluto, and it's one of my favorite pictures taken by New Horizons. But it was a snapshot in time. It gave us a good baseline for what are the chemicals in the atmosphere of Pluto, but it wasn't able to watch these chemicals evolve over a long period of time. Well, now James Webb has been watching and taking regular images of Pluto. And what it's found is that these hazes in the atmosphere of Pluto control the energy balance of the world. Pluto is very far away from the sun. It doesn't get very much sunlight, but it gets enough that it does warm up these gases in its atmosphere. And so as it warms up, these hazes rise in their altitude, and then they release a bunch of their heat, and that causes them to lower their altitude again, and then they can gather more energy. And this performs a kind of regulation in the temperature of the atmosphere of Pluto. And we don't see that in any other world in the solar system, just on Pluto. And so it just shows that, thanks to doing a flyby of Pluto and then following observations with a telescope like Webb, you can still learn a tremendous amount about what's going on at this world. We've got a great story about this by Carolyn Collins Peterson. Every week we do a vote on our channel where you tell us what you thought was the best space news story. And the winner last week was James Webb's longest exposure. So thank you everybody who voted last week. Now, while you're watching this, there should be another vote here on the channel. This is a way for you to tell us what you thought was the best story. So if you don't see that vote, go to the post tab. It should be there, and then click on a bunch of them to vote for as many as you have energy for. And then that will let the YouTube algorithm know that you want to see these votes. Now, the best thing to do, subscribe to the channel, click on the notifications bell, and then whenever the algorithm tells you to do things, you just do it. You don't question it. You just obey the algorithm. All right, from one icy world, Pluto, to another, Europa. And Europa is exciting because it seems to have this thick, icy shell around an ocean of liquid water. And this is one of the most interesting places that we could search for life in the solar system. The problem is that you've got kilometers of ice and then you have that liquid ocean. But what if there was a way that the liquid water was making its way from down below up to the surface? Well, there's new evidence that the surface of Europa has a mixture of ices on it that could give us an indication that some kind of water flow is actually happening. So we're going to talk about ice. On Earth, when water freezes, then the water turns into a crystal. And the ice that you are familiar with, ice cubes, that is crystalline ice. But if you bathe crystalline ice in radiation for long periods of time, it starts to break down, the crystalline shape of it starts to go away, and you get what's called amorphous ice. We don't see it here on Earth very often, but in a place like Europa, where it's bathed in radiation from space, as well as the trapped radiation from Jupiter's magnetosphere, over long periods of time, crystalline ice is turned into amorphous ice. Once again, James Webb to the rescue. Astronomers have looked at the surface of Europa very carefully, and they've been able to map out different regions of amorphous ice versus crystalline ice. So the amorphous ice is the older stuff. Crystalline ice could be newer stuff that is seeping up from inside Europa. And they see other things, cracks and fissures, and there seems to be a connection between where the crystalline ice is and where these surface structures are. And so it's really interesting that there could be some kind of process that is upwelling material from inside Europa and bringing it to the surface, which would make it a lot more easy to investigate. This is just preparing us for the arrival of the Europa Clipper mission, which is going to be going into these flyby passes of Europa at a very low altitude and should be able to confirm a lot of this just initial speculation. And if you want to read more, we've got an article from Carolyn Collins Peterson. As you probably know, I'm not worried about a lot of space-based dangers. Asteroids, meh. Black holes, come on. But solar storms, yeah, I'm a little nervous about the damage that a solar storm could do to Earth. One really bad solar storm could knock out satellites, disrupt power systems, cause havoc across planet Earth, disrupt our communications. It can be bad. And so we need to keep a better eye on the sun. But the problem is that where we are here on Earth, we only have one perspective of the sun. And so it's really hard. We don't have stereo vision. It's really hard to be able to know when various events that are happening on the surface of the sun are going to cause us a problem. So a new paper suggests that we should be launching a constellation of satellites that are watching the sun continuously from several different angles in orbit. That will allow them to spot when events are starting to happen on the surface of the sun, know if there's like a really bad coronal mass ejection that's headed our way. And then that gives us enough time to be able to disconnect networks, shut down systems safely and carefully, and so that when a solar storm does hit Earth, it doesn't cause excess damage to our infrastructure. So this mission would be expensive. You're looking at 6 satellites. They probably would have to take a Starship launch to be able to deploy all 6 of them. Cost billions of dollars. But, think about how much it would cost to recover from a really bad solar storm. So it probably is money well spent. And we've got a story about that by Andy Thomaswick. Now let's talk about flying to Mars. And typically, flying to Mars is a 6 to 9 month journey. There are a lot of exotic propulsion systems that have been proposed that could decrease that flight time down. Nuclear rockets, very powerful ion engines, magnetoplasma thrusters, solar sails. But right now, most plans are going with the tried and true chemical propulsion system. And that takes 6 to 9 months. But the problem is that for astronauts in space, they're exposed to a lot of radiation for that entire journey. And the other problem with a flight to Mars is that you have to line up when you're going to make your return voyage. There are these very specific windows that you have to take. If you want that 6 to 9 months, miss the flight window, and then it's a much longer journey. And so you have to wait for the flight window. And when you do a return mission from Mars, you either fly to Mars and then you only have a little over a month to explore the planet before you have to head home right away, or you have to wait on Mars for 18 months before you can return home. So it would be great to get more control about when you can do the flight. Now, with a rocket like Starship, a reusable rocket which can launch and then completely refuel in orbit and then make the flight, you can actually decrease the flight times, and it gives you that flexibility to launch at times when you're not hitting the exact window. There's a new paper out that suggests that you can decrease with Starship flight times to Mars down to 90 to a little over 100 days and get a lot more flexibility in when you go. You don't have to follow the exact launch window. But the problem is you can't come home at that same pace, because if you land on Mars, you've had to use a lot of propellant. You can refuel on the surface of Mars, but you have to use a lot of that up just launching off of the surface of Mars to then come back home. And so the new paper proposes that you could do orbital refueling at Mars. So imagine you send Starship, it lands on the surface of Mars, then just as they're proposing to do orbital refueling here on Earth, these things go into orbit, refuel each other, and then the return spacecraft is ready to go, and it can make that short flight time to come back to Earth. If you could drop those flight times down to just 3 months, that is like half to a third of the radiation load that you're expecting the astronauts to experience, not to mention the radiation they're going to experience on Mars. So that would be very good. And we've got a story about this by Matt Williams on Universe Today. Do you want even more space news? Well, I'm writing my weekly email newsletter, and this is where we cover 30 to 40 space news stories in text form and on the website. For example, a terrifying simulation of a black hole gobbling up a neutron star, and that's by Mark Thompson. What life on Europa needs, and that's a story by Dr. Paul Sutter, and how a Martian probe rolls over upside down to see subsurface ice and rock, and that's a story by Mark Thompson. I write my email newsletter every Friday. It goes out to 72,000 of my closest friends. It's completely free. There's no ads in it at all. Go to universetoday.com/newsletter to sign up. And did you know there's a longer version of this episode with one extra story? We call it SpaceBites Plus. It's completely free. There's no ads. You can go watch it right now. I'll put a link in the show notes. And this week's bonus story is all about why ozone isn't a good biosignature. I'm going to talk about how realistic science fiction needs to be. But first, I'm going to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, David Giltonet, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hen Schultz, Hudson Moore, Jay Graves, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, Monzo, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler Munley, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So if you're watching this on YouTube, then you know we have YouTube comments. But if you're watching this on Patreon, we also have Patreon comments. And we got an interesting comment on Patreon a couple of days ago that I thought I would respond to. So Rando says, I agree about sci-fi needing to be more in the story, and I do love a good galaxy-spanning space opera, but I think there's more room for more realistic sci-fi as well, and I think we don't see much of it because it's harder to write than when you can just say, and then FTL and artificial gravity. Thanks for the comment, Rando. And this is in response to one of my QAs where I sort of gave my position. And I think in general, you're right. And I think, when we talk about hard science fiction, both in literature as well as on television and things like that, movies, that there is room for the science to be harder. And for the parts that they can control, I think it's really good when a screenwriter or a director will bring in a science consultant who will actually help them make sure that the various bits and pieces of it are correct. Some of my science communicating friends have been brought onto various movies to help propose ideas, to look at the science, to do the math, and they serve an invaluable role as long as, it doesn't change the story, just all of the stuff that should be done correctly, they're able to go and take a look and make sure that it is done correctly. My favorite versions of this are things like The Expanse, where they obviously have a lot of stuff that is complete science fiction to us today, like fusion engines, but they think about how acceleration works, how the various G-forces that you experience on the body, and then they use those as a way to make the story more interesting and come up with conflict and situations that are outside of our normal experience. And I think that, my favorite example of this is in one episode of The Expanse, a bunch of tools fall out of a toolbox and are now floating freely inside a spacecraft that is attempting to do high G defensive maneuvers, and the tools are slicing back and forth, hitting people. And it's not the kind of thing that you would think of. It's not what you would experience if you just had artificial gravity. Everybody was walking around on their spacecraft. And yet it really enhanced the story. And I watched that and I was so excited when they did that. And so more of that, please. But I don't think we should be completely beholden to the laws of physics when we're telling our science fiction. The story has to come first. And then once you've got the story down, then do as good a job as you can to make the science match the story that you're trying to tell and our understanding of the laws of physics and science. So, I sort of sit right in the middle, but I lean towards story first. All right. Thanks for watching, and we'll see you next week.